Okay, we're doing some trig identities and we're trying to prove that the left side is equal to the right side. So let's start right away. So the first step is I'm going to get the common denominator for my left side. So I'm going to multiply this side by 10 and this side by cotangent. So let's get to work right away. So that's going to be 10 alpha multiplied by bracket 10 alpha minus cotan alpha over 10 alpha cotangent alpha minus, now this side we're going to multiply by cotangent because we want the common denominator to be tan alpha cotangent alpha. So that's going to be cotangent alpha, bracket cotangent alpha minus tangent alpha over the common denominator of tangent alpha and cotangent alpha. So the next step is, what we're going to do is we'll just expand these out, okay? So tan times tan is going to be tan squared. And then tan times cotangent is, well, tan theta cotangent theta minus, now cotangent times cotangent is going to be cotangent squared alpha. And then that's, and negative cotangent alpha multiplied by negative tangent alpha is going to give us plus tan alpha cotangent alpha over, over the common denominator of tan alpha cotangent alpha. Now what we can see is we can see that these two variables are going to cancel out. So that gives us tan squared alpha minus cotangent squared alpha over the denominator of tan alpha cotangent alpha. However, tan squared and cotangent squared are each trig identities, and I'll bring up a formula sheet to show you that. So bring it up right here. So as you can see that tan squared will be equal to 1 secant squared minus 1, and cotangent squared will be equal to cosecant squared minus 1. And we'll bring up our chart back again. So that gives us, well, so we know that tangent squared is going to be equal to bracket secant squared minus 1 minus, and we know that cotangent squared is going to be cosecant squared, oops, I didn't do my alpha, minus 1. Let's write the alpha there. Over, now tan is going to be sine alpha over cos of alpha, and cotangent is equal to cos of alpha over sine of alpha. And as we can see, the cos cancels out and the sine cancels out. And then now we'll just expand the numerator, so that gives us secant squared alpha minus 1 minus cosecant squared alpha plus 1, because negative times the negative gives you a positive, and our 1's cancel out, which gives us a final answer of secant squared alpha minus cosecant squared alpha, which agrees with our right side. So we prove that the left side, our left identity, is equal to our identity on the right.